Hey guys, we're going to take another look at Microsoft Flight Simulator and Link2FS. Last time we got Link2FS sending Microsoft Flight Sim data to an Arduino, and we got the Arduino to display the status of our gear lights. What we're going to do today is switch things up a bit. We're going to try and get the Arduino to talk to Microsoft Flight Sim. So, let's take a look. So today we're going to be using this little board I've built and an Arduino Uno again. This little board just has 3 switches, just on and off, 2 push buttons, and a potentiometer. And that's hooked up to pins 4, 9, 10, 11, and 12. The potentiometer is hooked up to analog 0, and of course 5 volts and ground. So let's go take a look at the schematic. So looking at the schematic here, we've got our 2 buttons, our 3 switches, and our potentiometer, and then of course the Arduino. Button 1 and button 2 are connected to pins 4 and 9. 4 and 9. The potentiometer is connected to pin analog 0, and the 3 switches are connected to pins 10, 11, and 12. And of course we have our 5 volts and our ground, and the Arduino itself is going to be powered on USB again. So for our buttons, we see our pin goes to one side, and the other side just goes directly to ground. This is because we're using input pull-up. We don't have to actually pull these to high. The same goes for our switches. We've got just our pin going to one side and the other going to ground. So basically it's always going to be reading high. If you press the button, it makes contact and it brings it low to ground. So in our software we're going to be looking for low to be active. It may seem a little bit backwards, but that's how it's going to be done, just because we're going to use the input pull-ups. If you're actually using resistors, you can pull it up or pull it down. So here we have our potentiometer. Now this is hooked up to analog 0. So a potentiometer. A potentiometer you can think of as a variable voltage divider. So you're going to have your 5 volts and your ground, and then essentially, as far as your circuit's concerned, in between you're going to have 2 resistors. We're going to focus here on a 10K potentiometer, which is going to be probably the most common one you come across. So just looking at this, it's in the middle. It's halfway. So in this configuration, you have 5K there, and 5K there. That means here, you're going to have 2.5 volts. Now, I'm not going to get into the theory and math behind a voltage divider. There's plenty of info available online that's probably much better than I can give you. But the easy way to think about this is as you move this wiper toward the 5-volt line, your voltage is going to go up. As you move it toward the ground, your voltage is going to go down. Less resistance between your power source and your analog pin means more voltage is going to get there. So if you add more resistance here, now let's say it's 75% of the way toward positive. So now you're going to have, let's keep with some common value. No, let's just go, you got 2K there, you got 8K there. So now if we have 8K over here, and 2K over here, well, this is 1/5 the resistance, so we're going to get 4/5 the power here. We're going to get 4 volts. Now, the Arduino does something nice for us. It actually has an ADC, an analog to digital converter, built in. So what the Arduino does without us having to do anything, once we read that analog pin, it's going to give us not 4 volts, but a value between 0 and 1023. So what we're going to do with that in software is map that to a value of 0 to 100, which is going to be our flaps percentage in this case, just as an example. So that's pretty much the schematic. Let's go take a look at the code now. Okay guys, so let's take a look at Link2FS. If you watched part 1, you should already have this somewhere on your computer. I just placed it on my desktop for now. So, in Link2FS, it doesn't really matter if you've already got settings saved from last time. All we're going to look at this time is not keys inputs, but SimConnect inputs. Now, SimConnect is an add-on program for FSX, but a version of it for this particular program, Link2FS, is apparently included. So you shouldn't run into any errors. If so, I'll probably do a video about SimConnect itself later on. Anyway, in this tab, SimConnect inputs, you're going to see a column here with just letters and numbers, and then a column here with these are the descriptions of what these represent. So basically, if we send A02 from the Arduino to Link2FS, it's going to increment the COM by 1 MHz. And if we were to send A03, it would decrement the COM by 25 kHz. But we're concerned about something down here. C17. Now you'll notice it has 3 X's beside it. Now in the description, sets flap handle to closest increment, 0 to 100%. And then, again in brackets here, C17 with 1 to 3 digits. Meaning from the Arduino we need to send C17 with no spaces, include the... This means from the Arduino we need to send C17 and the percentage from 0 to 100 with no percent symbol, just the numbers 0 to 100. We'll look at that a little more when we actually get into the Arduino code. But if we look just up a little bit here, we've also got C01 and C02. We're going to use these ones as well. Those are to set the gear handle in up position and set gear handle in down position. We are also going to be looking at a couple of the light codes. We're going to have nav lights, we're going to have landing lights, and we're going to have cabin lights. Now these ones you'll see they're C41X. The X will be a 1 or a 0. 1 being on and 0 being off. So for example, if we want to turn the nav lights on, we send C411. If we want to turn the nav lights off, we send C410. So we're going to grab the nav lights, the landing lights, and the cabin lights from here. So altogether that's the 3 lights, gear up, gear down, and the flap handle percentage. So that's going to be 3 switches, 2 buttons, and a potentiometer. So that's all we're going to actually have to look at on Link2FS for now. Let's go to the Arduino code. Okay, the code. So up here, commented out, we just have my website and my YouTube channel, and then a description of what pins are doing what, and what codes are being sent to Link2FS. We've got these neatly labeled into switches, buttons, and potentiometer. So getting into the actual code here, we don't have to include any libraries or anything like that, so let's just get right into it. We're going to set 2 variables. These are both just for the potentiometer. The first variable here we're going to set as an integer. I'm just going to call it flap read, and that's going to store a value from 0 to 1023 when we actually read the potentiometer. And then the second variable is going to be to store the mapped potentiometer value. That'll make a little more sense in a couple seconds here. So our setup is pretty simple. We begin serial at 115.2K, and then all we're going to do here is set all of our pins except our analog, all the digital pins, so 4, 9, 10, 11, and 12, we're going to set those all to input pull-up. That's all 3 of our buttons, or all 3 of our switches, sorry, and our 2 buttons. We don't have to declare analog pins. I'm not 100% sure on the specifics of why, or if that's in every case. I know you have to declare them if you're going to use them as digital pins. Because the Arduino, you can actually use the pins labeled analog as digital. But in our case, in this code, we're not having to declare the analog pin as anything. So that's our entire setup. Moving on to the loop, which is where everything happens. This is everything to do with the flaps. This is everything to do with putting the landing gear up. This is everything to do with putting the landing gear down, and etc. So let's look at the actual code here. The first thing we're going to do is read our analog pin. That's going to be analog read 0, and that value is going to be a value of any number between 0 and 1023. We're going to take that value and store it in flap read, and then moving on to the next line, we're going to take our other variable, flap map, and we're going to map the value in flap read, which is going to be a value of 0 to 1023. We're going to map that to a value of anywhere between 0 to 100. And store that in flap map. Next, we're going to serial print. That's important there. This is a serial print, not a print line. So a serial print is going to print whatever's in these brackets. It's going to be literally the characters C17 because it's in quotes. So we're going to print C17 with no line ending. So in the code, or in the serial monitor, or Link2FS, it's going to look like this. Notice the cursor's still right there. As opposed to a serial print line, if we were to serial print line, it would add a carriage return. We don't want that in this particular case. So we're going to use serial print. We're going to print C17. So we look up here, C17. Now we need 1 to 3 digits. Oops, sorry. There we go. We're going to need 1 to 3 digits. So the next line of code, we serial print line the contents of variable flap map. There is a variable named flap map in this sketch, and this isn't in quotations, so it's going to actually print whatever's in that variable instead of actually printing the characters FLA, etc. That's where your quotes come in. Now the serial print and then serial print line, that's going to, you would think it would come up as C17 and then we're printing again, so then we'd come up with our values, say it's 40. But that's why we're doing a serial print and then a print line. So in the code it's actually going to come up, it's going to serial print C17 and then serial print line C40. So it's going to print 40 and then a line return. So that's what we're going to actually send to Link2FS. And that's all we're going to do for flaps. So moving on to the gear up, we're going to do a while statement. I honestly can't remember why I'm doing a while statement. I must have run into a problem with if statements for my gear buttons. If I remember, I'll add an annotation. But anyway, we're gonna do a while statement here. So while digital read 9 equals low. Now what does that mean? Well, in our schematic, we referenced that we have no pull-up or pull-down resistors because we're using input pull-up. What this means is the Arduino has internal resistors that will pull up a pin without you having to actually add a resistor. Now, one consequence of these being pull-ups and not pull-downs is that our logic is going to be inverted. So what we're looking for in this line is the button to be pressed. If our logic was not inverted, we'd be looking for high. But because the Arduino includes pull-ups and not pull-downs, our logic's inverted, we're going to be looking for a low. So, while pin 9, or our gear up button, is pulled low, or pressed, serial print line C01. And it's as simple as that for the gear. It's the exact same for gear down, except we're going to look for pin 4 to go low, or be pressed, and we're going to print C02. So that's our entire gear. Gear up, gear down. Moving on to our lights. We have 3 switches here, which are going to control 3 different lights. As you can see, they're going to be our cabin lights, our landing lights, and our nav lights. So, to start, we'll do our nav lights here. We're going to do an if statement here. So, if digital read 12 equals low. So if pin 12 is pulled low, because again, all of our switches and buttons are on pull-ups, inverted logic. So if pin 12 is pulled low, or switch is in the on position, we're going to print line C411. And that's going to turn our nav lights on. Else, so if pin 12 is high, we're going to print C410, which is going to turn our nav lights off. Moving on to landing lights, it's literally the same thing, different pin, different code. So if pin 11 is pulled low, we're going to serial print line C431 and turn the landing lights on. Else C430. And then again the exact same thing for cabin lights. If pin 10 this time is low, then C501, else C500. And that is the end of the code. Alright, so if we open up Microsoft Flight Sim and Link2FS, which my computer, as you saw in video 1, is pretty buggy with these 2 programs, but we've got it running well enough to show you this. So here we have the Arduino with a little custom board that I've made. It's got our 3 switches, our potentiometer, and our 2 buttons. So if we throw the middle switch here, we'll see our landing lights come on. if we look to our left here and throw this switch, we'll see our nav lights come on. This third switch I have set up for cabin lights, as we saw, and I found out none of the planes on my computer actually have cabin lights. So we're gonna switch that out really quickly and look at something else. I think I'm gonna try and do the Master Avionics switch. But if we move on here, for now, since it'll be about an hour before I get to that with all the crashing and booting and testing, we'll take a look at everything else quickly first. So if we hit the gear down button, we're going to see it moves the handle. We're on the ground, so it's yelling at me now, so I'm going to hit the gear up button. And we see it moves the handle, and now gear is safe again. Now we're going to turn the potentiometer. Should be that one. There we go. We see a wing flap here. This particular plane only has certain settings, so once the potentiometer hits that setting, then it goes to it. So you'll see here, we're about a third of the way up now. And then all the way back down, or up. So, I guess let's jump back over to the code. We'll change this switch to hopefully this switch right here is Master Avionics. Maybe this one. I'm not a pilot, so I'm not too sure what half of this stuff does. But I will find a switch that works. We'll code that in and we'll test it out. So looking at the code here, we're going to change up in the comments. First of all, cabin lights is going to be A43X now. You get it. I'll fix this code up before I actually put it on GitHub. Speaking of which, the link will be in the description. We're going to cabin lights, which is now going to be Avionics Master. And these are now going to be A431 and A430. So let's upload this code. Keyboard shortcuts. I gotta go upload. Oh, if you run into this error and you happen to have Link2FS open and running, that would be why. Now, because my computer is crashing at the moment, I'm going into my task manager and I'm just gonna end that process. Yes. Go back to Arduino, Control U to upload. Done uploading. So now, if I go back to my desktop, and I open. Okay guys, my computer really crashed pretty bad that time. So we're not gonna try the green capture for this again. But we're right back where we left off here. I've got Microsoft Flight Sim open. So let's go ahead and open Link2FS. Let's plug in our Arduino. Let's connect our Arduino. Open FSX back up. Let's plug in the Arduino. Let's connect it. Go back to Microsoft Flight Sim. Unpause. And there's our landing lights. So, if we look down here, our third switch here, that was our cabin lights, should now turn our radio on and off. Avionics. Now before I sign off here, I'd like to actually bring up some code written by the guy who actually made Link2FS. I'm not 100% sure what his name is. It's obviously Jim. But his website here is jimspage.co.nz. I mentioned him in the first video, but I didn't give him a proper shout out. Jim, if you see this, thank you so much for writing Link2FS. I've had a much easier time interfacing with Microsoft Flight Sim than I have with X-Plane, and that is thanks to Link2FS. Jim here, he provides his own code. It's much better code than mine, I will admit that. But I just think my code's probably a little bit easier for the beginner to actually manipulate. Alright guys, so that's been a quick look at Link2FS inputs. In the next coming weeks we'll take a look at a few other things. We might take a look at rotary encoders. We might take a look at some sort of display, either LCD or maybe 7-segment displays. We might take a look at servos. I haven't quite decided what to cover next. Plenty of options. Link2FS has tons of options available. So this series could keep going on for quite a while. It just depends how much you guys want it. So on that note, like, subscribe, dislike if you want. Always leave a comment, guys. Have a good one.